I'm neither a techie or a scientist, but I wanted to see if I could use AI to figure out the genetic cause of my daughter's autism and epilepsy. Here's the first video on this vibe coding journey. So, my daughter, who is now 18, was diagnosed with profound nonverbal autism at 12 months old, and later would start having seizures around age 10. Despite taking 4 different medications, she still has seizures at least once a month, sometimes 2 or 3 times, and this is called drug resistant epilepsy. Now, in 2023, we had our whole genome or exome sequenced through a company called GeneDx. The report came back showing no genes of interest, meaning nothing was actionable. And while I didn't expect to find a single driver of our condition, I was hoping for some insights into the potential genes or targets that could be followed up on with later research. Now, in the past year, I've seen a lot of news about different AI tools making scientific discoveries, as well as new large data sets on genomic data becoming available to researchers for free. I wanted to know, could I use AI tools to do a deep dive on her genetics, then compare it to scientific literature and public data sets and find anything interesting? There are a few problems with trying to do this. One, the genetic files from the company GeneDx are too large and written in a special language that most computers can't open or read. And even if they could, it's not like someone like me, a non-specialist, could understand them. So I turned to Claude Cowork, which is an AI system with an agent that can do tasks for you. Claude, along with other AI companies, have been integrating more and more medical research tools into their systems, so I thought, why not give it a go? I described to Claude what I was trying to do. I wanted to analyze my daughter's raw genetic files and see if we can come up with a strategy to search through public open source data sets, published research reports, scientific studies, and other medical research to identify potential targets for further research to link to our condition. My first attempt hit a brick wall. The files were too large, so I couldn't attach them directly to the chat, and the chat couldn't access them on my Google Drive either. It was being blocked for some reason. So I decided to try it again in a new chat window. This time, I moved the files to my computer's hard drive and gave Claude access to that folder. And I clicked on a special bioresearch prompt at the beginning called Scientific Problem Selection. This gave it, the chat, a better sense of what I was looking for, and this time it easily read the files and got to work. After reading the materials, it told me that it looked through more than 200,000 variants in her files. Then it identified 232 that were both unique to her and located in genes tied to neurodevelopment. One in particular stood out, a sodium channel gene called SCN2A. It's basically part of the wiring that controls how brain cells fire. Claude suggested that my daughter may have what's called a loss of function variant in this gene. Now, it's important to understand this term. A gene can cause problems in two opposite ways. One, it can be overactive or doing too much. Scientists call that gain of function. Or it can underperform, which means not doing its job well enough, and that's called loss of function. The reason this distinction matters is that the treatment approach is opposite. If a gene is overactive, you want a drug that can calm it down, but the gene is already underperforming, drugs that suppress it at even more could make things worse. So in the published research, there was a recurring pattern connected with loss of function in the specific gene that Claude had identified as different in the genetic files. For people who have underperforming gene, autism shows up early in life, and then hard to control seizures can follow later on in childhood. That's basically my daughter's experience. Next, I gave the system a list of medications my daughter is taking for her seizures, and it told me that 2 of the 4 she's on right now are sodium channel blockers, which may be a bad match for her genetically. Published data on certain cases show that those drugs have been linked to worse seizure control in these certain patient groups. One paper reported that about 22% of patients got worse on one of these drugs in particular, and it's one of those very common medications that a lot of people on epilepsy end up taking. Now, before I got carried away, I asked Claude for a gut check. I asked, can you really tell from these files that her genes have a loss of function variant? And it was straightforward with me. It said, we know her copy of this gene has 3 differences compared with yours or my own, because I gave them my genes as well. And it said we can't tell if it's one of those 3 differences actually break the gene or not. So think of it like finding 3 typos in a recipe. Some typos change the whole dish, others don't matter at all. The file I have show where the changes are, but not what they do. The extra layer of information wasn't included in the files that I got back from GeneDx. So the loss of function idea isn't based on proof in the files, it's based on how closely my daughter's medical history matches the published pattern for this gene. It's a theory, it's not a confirmed finding. But it is a specific testable theory, and that's something that we can further investigate. Now, given this info, I've reached out to her neurologist for her thoughts. It may not be anything concrete, but at least I feel like I'm learning more and potentially developing a tool that could help one day provide more answers to my family and potentially for other families as well dealing with similar genetic conditions. Thanks for watching, and be sure to let me know what you think in the comments.